Intermediate Algebra, Section 9.5, Changing Logarithmic Bases. Most calculators can find both common logarithms and natural logarithms. To find a logarithm with some other base, a conversion formula is often needed. And here's an example of, or the formula for, the change of a base. For any logarithmic base, a and b, and any positive number m, the log base b of m is equivalent to the log base a different base than what we started out with, of m, which we're taking the log of, over the log of this new base of the old base. Typically, the new base will either use a common logarithm, so we would use a base of 10, or a natural logarithm, and either one of them will result in the same value. And let's take a look at how this change of base formula works. Given log base 3 of 6, we're stuck. We can't convert the 6 into a number that has only 3 as its base, so we have to do something else. And the something else is to change this to a different base. And I'm going to change this to a common logarithm, which would be a base 10. So using that formula that we just had, log base 3 of 6 is equal to log base 10, the new base of that quantity, over log base 10, the new base of the old base. Now I wrote the old base down, but I could have just written log of 6 over log of 3 using the shorthand for common logarithm of base of 10. And simplifying this, because they're both logs, doesn't mean that we can take 6 divided by 3 only if it had been a single log of a quotient, and it's not, so we have to follow order of operations, simplify the numerator, simplify the denominator. So I'm going to take the common log of 6 and divide it by the common log of 3 to find the result. I get a 1.63, and just to check that, we would have the log base 3 of 6 is equal to 1.63. Exponentially, the equivalent would be the base 3 to the 1.63 power should be 6. Now there was some rounding in the value, so it may not come back exactly, but let's see if that works. So I want to find what 3 raised to the 1.63, the answer that we got is, and it should be close to 6, and as you can see, I get a 5.99. I'm satisfied with the rounding that this problem was solved correctly. Now, as I mentioned, there's no hard, fast rule that you have to convert this into a common logarithm. We could also have converted it into a natural logarithm as well, and we still would have come up with the same answer. Proof of that is, I'm going to illustrate that in this next problem. They're asking us to find the solution to log base 5 of 9.2. There is no way that we can convert 9.2 into a base of 5 to solve this, so we will convert it to a different base using our change of base formula, and this time I'm going to convert it to a natural logarithm using a base e. So log of the new base of what we were taking, 9.2, over log of the new base of the old base. And I wrote this out completely showing the base, but I could have used the shorthand ln, natural log of 2 over ln of 5 for an equivalent version of the given logarithm using the change of base formula. So to calculate this, we will take the natural log, in other words, the ln of 9.2, and divide it by the natural log of 5, giving us a value of 1.3, and rounding it to the nearest hundredth, I'll call that 1.38 would be the value. Similarly, we could do a check. Exponential form that's equivalent to this logarithm would be the base 5 raised to the 1.38 should be something approximately close to 9.2. This would be our check to see if we've solved this correctly. And just to show that, the base 5 raised to the 1.38 power is very close to the 9.2 that we started with. So we can be satisfied that our answer 1.38 is correct.